Hey everybody, it's Mrs. Conway. So hopefully you've already watched the video about Elon Musk and exponential functions. I just thought that was kind of a fun way to introduce exponential functions so you can see some ways that they apply to the real world. Exponential functions are huge in finances. So now let's talk about what an exponential function is. So what I want to do is I want to start by comparing exponential functions to some other functions that you may or may not have seen. Okay, you've seen linear functions. I assure you, you have. Half of you have seen linear functions. I know this because I'm the one that taught them to you. So linear functions are what you're really used to seeing when you think about a function, and that's constant rate of change. So if you think back to your Algebra 1 days, linear functions are increasing at a constant rate, which means that you can subtract to find your constant rate of change. So right here, first of all, you want to check these are all going up by 1. But I don't know if you guys remember doing this. So 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. 4 minus 5 is 1. And you'll notice all these are going up by 1 for x. That just makes it easier to see patterns. So right here, for a linear function, you want to subtract 2 minus 1, bottom minus top. And you should, if it's linear, 3 minus 2, get the same number every single time you subtract. So you can see here on this one, we subtract along and we get 1 each time. So we know this is linear. And I know, and I hope you guys know, that the equation for this would be y equals x, because the rate of change is 1, which would be your slope. So there'd be 1x. And if you go back 1 here, like this is going up by 1, you would have 0, 0, which means that it goes through the point 0, 0. So I'll just scroll down really quick here so you can see what this graph would look like. So that is how tables of exponential or linear functions look. That's not what we're doing next, but this is something you might be familiar with, so I put it on there. Exponential functions are going to be different. If you see here, if we start subtracting, 1 minus 2 is going to be negative 1, but then 0.5 minus 1 is negative 0.5. And then this would be negative 0.25. So we're not going to have the same number every time when we subtract. So we're going to divide. I'm going to change my pen here. So what we're going to do here is we're going to do the same process, but instead of subtracting, we're going to divide. So right here, you're going to do 1 divide 2, and that will give you, well, 1/2 or 0.5. Then we're going to do 0.5 divided by 1, which is, well, 1/2. Then we do 0.25 divided by 0.5, which is, you might think of this more as 0.5, but it's also 1/2. And again, 0.125 divided by 0.25, and we're going to get 1/2. So you notice as we go down, we're going to get 1/2 each and every time. So we have a constant ratio or a constant factor. Again, so you can see constant rate of change is 1/2. So our exponential factor is 1/2. We're dividing by 2, which means we're multiplying by 1/2. So you can see down here, here's our function, y equals 4, because if we went back to where x is 0, we'd be at 4 times 1/2. That's where that 1/2 is coming from, to the power of x. And when we graph this, we get a curve. And because it's going, the numbers are getting smaller, our graph is curving down. Obviously, if they were getting bigger, it would curve up. Okay, the last type of function that I want to talk about that's part of Algebra 2 is quadratic functions. So quadratic functions are they don't have a constant rate of change. They don't have a constant factor. What they have actually is a constant rate of changing their change. So with quadratics, you want to subtract just like you do with linear. The other way you can tell if it's quadratic, if it's not linear, it's not exponential, and it's a function, in this problem set, it will be quadratic because that's your only other option. But let's just really quickly demonstrate what quadratic is from a table. So here we do 2 minus 6, and that would give negative 4. Here we do 0 minus 2 is negative 2. 0 minus 0 is 0. 2 minus 0 is positive 2. So you can see here, not the same. So it's not linear. If I divide, 2 divided by 6 is 1/3. 0 divided by 2 is 0. 0 divided by 0 is undefined. So this is definitely not an exponential function. But what we can do here is now we can subtract again. Negative 2 minus negative 4 is actually going to be positive 2 because we're getting bigger here. 0 minus negative 2, again, is positive 2, and then 2 minus 0 is 2. So you can see if we subtract again, we do the second differences, we get that we now end up with a constant number. So that is the definition of what a quadratic function is. Another big hint that it's quadratic is if we graph it, you see we get this U shape. So, and the quadratic function here would be x squared minus 7x plus 12. You can't see the plus 12, but that's what it is. So linear makes a line, exponential makes a curve, and quadratic makes a U, or if it was a negative, it would be a mountain shape. And again, linear, you're going to subtract, and if every time you subtract you get the same number, then it's linear. If you divide and get the same number, it's exponential, and if neither of those two things happen, but it's still a function, it's quadratic. Now what is going to happen in this problem set is you are going to get some that are not functions. And I just really quickly want to kind of warn you about that. So, and there were a lot of them. When I was trying to find examples for this, I kept accidentally finding ones that weren't functions. So you need to check the x values to tell if it's a function. So I don't know if you guys remember this from Algebra 1, but a function is a relation where each input has exactly one output. If we look here, this function or this relation, 5 goes to 2, and then over here 5 goes to 0.5. That's not a function. You can't have x repeat itself. So you just have to watch, because I think it's almost tricky the way that it happens. And then what you would see if you were to graph that is you'd have, I can't graph it as a curve because it wouldn't make a curve, because see right here where the 5 is, you'd have 2 dots stacked on top of each other. That's no bueno. You can't do that. So not a function because of that. So check your x values. This is not a function because x repeats. But that's really all there is to this first little problem set. So you're going to check if it's a function. If it is a function, then you want to, I would start by subtracting and seeing if it's going up by the same amount each time or down. Then it's linear. And then check division. If it's multiplying or dividing by the same amount each time, it's exponential. And if it doesn't do any of those and it's still a function, then it's quadratic. So good luck with this problem set.